Chapter 4, Section 4 begins with the Big Bang. And the Big Bang occurred between 12 and 16 billion years ago. The universe was so tiny that it was able to fit on a pinhead, and it exploded. And when it did, the temperatures were so hot that only energy was able to exist, so there was no matter yet. We're talking about millions of Kelvin. And as it expanded after the explosion, it started to cool down, and the first atoms were able to form. Mostly hydrogen, but some helium. So some of that energy was able to be converted into matter. And as clouds of hydrogen started to accumulate over time, gravity would pull them closer together. And as it pulled them closer together, it would increase the pressure and the temperature within them. And that's how some of the first stars were formed. Now, in those very hot centers of the stars, that's where nuclear reactions can take place. And nuclear reactions are just a reaction that involves the change in the composition of the nucleus of an atom. One type of nuclear reaction is a fusion reaction, and that's how many of these elements came to be, is by fusing multiple hydrogens and heliums together to form larger atoms. The higher the temperature is, the larger the element that can be formed. Now, on our periodic table, there are 93 naturally occurring elements, or ones that just occur out in nature, and then the rest of them are synthetic elements. So synthetic elements, or man-made elements, can be put together in some different ways. One of those is through transmutation, which is another type of nuclear reaction, where you change one nucleus into another by either radioactive disintegration, where you're breaking down that nucleus, or by bombarding it with other particles and causing it to get larger. A couple pieces of equipment that are used to help make these synthetic elements are the cyclotron and the synchrotron. The cyclotron was invented by an American, E.O. Lawrence, in 1930. And what it does is that it will accelerate charged particles to a very high energy, so it'll make them move really quickly. The synchrotron then helps to time impulses to match this acceleration of those particles. So essentially, the cyclotron speeds the particles up, so they're moving very fast, and the synchrotron is going to time them so that they will run into each other. And by running into each other at a high enough energy, that will force those elements to fuse together and make a larger compound. So those are used to make the super heavy elements, which are elements that have an atomic number greater than 106. Now, some of these are not extremely stable elements, and people are still working on trying to make more stable large elements.